Hello, Augies Worldwide. I'm Dave Kessler, amateur radio call sign KE0OG, with another episode, number 302 of Ask Dave. Today we're going to talk about an interesting variation of a dipole. It was sent to me by Jerry Buston, who lives in Boise, Idaho. And it turns out that this is an antenna that he made in the 1970s in Okinawa. And he also publishes a book called HF Wire Antennas, which is out of print at the moment, but has just been revised, and he will be, I think, probably publishing that through Amazon fairly soon. This antenna, and we can look at it right here, this is a Jpole. Jpole antenna, but it's fed rather oddly. Let me just zoom in on this so that you can see just how oddly this thing is fed. Normally, and this is the short part, and then this is the long part that goes on for another half wave. We would feed it about here, across both here and both here, and it would be a balanced feed because this lower part right here is the impedance matching part. But this is fed entirely differently. We're putting the shield with the bottom here, okay, and it is actually physically connected to the two wires. These are stainless steel, by the way, that have been heat treated to bend a little more easily. And then the center conductor, and you can see the quality of the workmanship here. The center conductor comes up over here where it is wound around the antenna without touching it. Now, he says this is inductive coupling, although I would say it's capacitive as well because it's so close to there. In any event, what we're going to do is put this thing up and see how well it goes. Now, there's no part sticking down like there is on a lot of Jpoles, but there is a hole in here, and I measured the diameter of the hole and came up with, let's see, outer, inner. Okay, inner is 3/8 of an inch. So I went down to Home Depot and I bought a 3/8 inch threaded rod because otherwise they don't have any really long 3/8 rods or rods that are just threaded for a little bit. And what we're going to do is put this up through here, okay, and I'm going to put a washer here and a bolt here. Well, you know, it's probably easier if I put them on the other end first. I'm going to put this on here. Okay, with a washer through the hole, a washer, yeah, it's fighting me. Okay, the other 3/8 inch nut here. Now we're going to use the shank of this threaded rod. Okay, I'm going to make that real tight with some pliers. I'll do that offline. Now I've got this threaded rod sticking out here, and this is what I can hook to the mast with appropriate hose clamps. So I've got something that'll grab the mast. Now, the problem with doing that is that threaded rod, by its very nature, a crack can form in any one of these threads. So this thing's not going to be dreadfully strong, but it just has to hold a Jpole up. So I think it'll probably be okay. I'm going to remove from the mount that I've got out there right now. A antenna that I picked up at a ham fest. It may look like a name brand antenna, but it's actually a cheap knockoff. And you get what you pay for, and the antenna does not work very well. So I'm going to replace that dual band antenna with this antenna, which is a single band Jpole for 2 meters. And then I've got another antenna for 440 that's a beam, a 10-element beam that I put in a while ago. I also got from MFJ a little coupler so I can bring both the 440 and the 2 meter together on one coax coming into the house, which will save me a coax connector, which will be nice. I can then use that other coax connector for testing. So that's where we're going to stop with this one, with its unusual feed arrangement here. And I'll hook the coax up to here, and we'll just do the standard measurements like we would do with any antenna. And then we'll put it on the air and see how well it works. Okay, this is the antenna we're taking down. And it's held in place by these clamps to this piece of aluminum fence. Well, I guess it's steel fence top rail. So we're going to find the right tool here. I think it's this one. Nope, it isn't. Something smaller. How about these? No, something smaller. How much you want to bet it's metric? Hey, we got to find out what this is here. This is what's holding the thing in. I'm going to put this up like this, and let's try 10 millimeters. That's exact. Okay. Get out all the way. I believe this comes up like that. Okay. Put that down like that. Now we've got to get that. Oh, gross. When I put this thing on a few years ago, I put this self-sealing tape in here, and I should do this with a knife. Oh, there we go. Okay, this is off. There. Now we need to take off this piece here. Now that my hands are all sticky from that tape. I don't know if you can see this. That's gross. Okay, another 10 millimeter screw. We'll put that in the box. The others, 10 millimeter. Well, it's not a screw, it's a nut. Now we're going to pull the cable through, and then that comes out. And now we need to go get a 10 millimeter open-ended wrench for these so we can take these off. And then we're going to clamp the new antenna right here. This is a 10 millimeter wrench. When I worked at a motorcycle shop many years ago, 10 millimeters was a real common size. There's something called ISO, International Standards Organization, and they do for the world what the Society of Automotive Engineers does for the US, and that is that they set the size for everything. Okay, that looks good there. Okay, let's bring out the antenna. I'm going to put this down. One more level. We're up. I don't really care for ladder work. All right, this is going to go like this, and we're going to strap a couple hose clamps on there to hold that in place. So let me just stick it in there. Here's a hose clamp there. And I'm going to put one, I think, down here. Okay, now we're going to put this down through that hose clamp. Okay. We need that around. Ouch. Normally I use a 5/16 nut driver, handheld nut driver for these, where I have misplaced it, which is very frustrating because that 5/16 nut driver was the most frequently used nut driver. Okay, it's on there tight. And we're going to put the cable up here. There. Okay, it's mounted. And we will make our tests from this mounting. Whew. All right, we got it up in place of the old antenna, and it is connected using the same coax the old antenna used. So let's take a look at the SWR. What we're looking at now, let's go to the bottom of the, oh, it went to sleep. Okay. Okay, we're going to go down to 144, 3, 4. Okay, that's the bottom of the 2 meter band, and it's a perfectly acceptable SWR of 1.5. Let's go to 145. Okay, still good. 146. And it's 1.4, still very good. 147, And 1.3 still good. 148, which is the top of the band, at 1.2. Now let's just find out where the lowest SWR is. The lowest SWR is at 149.51 megahertz. So the antenna could be a titch longer, but it works fine. And this is the resonant point because X is completely zero at this point with 56 hertz. So I think we can safely say that the antenna works. Now I'll be connecting that to my 2-meter rig here and doing some testing on that for another video. But in the meantime, it's been interesting to look at this unusual antenna design. Now I am going to put on my website the drawing for how this thing is built. If you want to give it a try, it's got a little bit different interface. I think it's probably could be called an unbalanced interface. And it seems to me that it works quite well. So this antenna, which was first invented in the 1970s in Okinawa in response to some Army requirements, has come down to us and is available. Now, when I talked with the inventor here, which is Jerry Buston, he is, by the way, KR7KZ, Kilo Romeo 7 Kilo Zulu. He is not manufacturing these anymore. He's long retired. This one that I tested today was prototype number 33. So it was one of the early versions, and it does work quite well. So this could be a project for you or your club to try something like this. Note that, as you can see from the drawings, being a good machinist would be a really good help. And it can be put together readily in that environment. I'm not a machinist. I wouldn't try it myself. I'd stick with the traditional Jpole. So there you have it. We'll do some comparisons now because this has freed up a lightning arrestor. So I'll be putting a regular Jpole on the other one, doing some comparison tests to see which design is better. Now notice there's no manufacturer here mentioned. You can't order one of these antennas. You could build it yourself. But look on my website at dcasler, DCASLER.com. and sort through the posts on the page or search the site for unusual Jpole, and you'll find the drawing for it. So there we have it. We're in the 300s now on Ask Dave. I think this is totally cool. Now, if you're watching this, please note that the Amateur Extra training videos have been updated for 2020. So the latest videos are available on YouTube. They're also available as a thumb drive if you would prefer to look at it that way. For details on that, go to ke0og.net/extra. All right, until we next meet, 73.